Hi, sixth graders. This is Miss Young. This is a video going over your Chapter 6 practice test. Make sure you try it on your own first. The practice test looks a lot like the real test. Your practice test has more pages, so these first 2 pages of the practice test are the questions that are most like on your real test. So pause the video as you go, slow it down, repeat parts, make sure you understand every question. Question 1. Write an expression to represent the length of the line shown below. Make sure you include X and Y in your expression. So we have this line segment here that goes from this red part to this red part. An expression is like an equation without an equals. So the first thing I want to do is right underneath it, right? This part is length X. This part is length X. This part is length Y. And notice X is a mystery number, but these X's have to be the same number. This Y could be a different number. We're also going to add on the part that is 2 and the part that is 7. Now this is an expression, but we're working on simplifying it. So if you have 2 X's, that's like 2 times X, and we write that in math like 2X. There's an invisible times symbol between the 2 and the X. Then we add on the Y. And then 2 and 7, we can combine those. 2 and 7 combined is 9. Then it says evaluate the expression when X equals 4 and Y equals 5. That means we substitute in those numbers. Since X is 4, we put in X instead of 4. Since Y is 5, we put in Y instead of 5. So instead of 2 times X, I'm going to have 2 times 4. And instead of Y, I am going to have 5. Then I use my order of operations. And that you remember often with PEMDAS, but we only have multiply and add. So we just need to make sure we multiply before we add. 2 times 4 is 8. Then we still have to add on the 5 and the 9. 8 plus 5 is 13. We add on that 9, we get 21. So the expression is 21. That's the value of it when we substitute in 4 for X and 5 for Y. This next part, it helps to have a number line. So our first number is our starting value. If you would like a number line, let me know. If you start at 5 and you take away 8 or subtract 8, you're taking away more than you have. So you're going to go negative or go into debt. But I'm going to move over to show you a number line. So we had 5 minus 8. If we start at 5 and we go back 8 spots, 1, 2, 3, 4, 5, 6, 7, 8, we get negative 3. That's our answer. Let's try number 3. So we begin at our first number at negative 9 and we add on 4. So I'm going to write down the problem, negative 9 plus 4. I start at negative 9 and I add on 4. Remember, when you add, you go this way to the right. And when we subtracted, we went to the left. So add on 4. 1, 2, 3, 4. We end up at negative 5. So we got closer to 0, but not quite there. These straight up and down lines that are kind of like parentheses around a number is absolute value. That's distance from 0. So we say, how far is 5 from 0? 5 is 5 from 0. How far is negative 3 from 0? It's 3. So it's kind of like a machine that turns all things positive or non-negative. Then we just have 5 plus 3. And you don't even need a number line for that. You get 8. Okay, so we have absolute value of negative 2. That is positive 2. This minus sign is not inside an absolute value, so I need to write it again. Absolute value of negative 5 is positive 5. So we're going to have 2 minus 5. So if I use a number line for that one, I start at 2, and minus takes us to the left. I'm taking away more than I have. 1, 2, 3, 4, 5. So when I take away more than I have, I end up with a negative number. In this case, -3. So on the test, make sure you're showing this layer here. If I use a multiplier, so if I multiply by 4 on a picture, what would happen to the side lengths? So if you had a side length and you made it times 4, it would not stay the same. It would not get smaller. It would be an enlargement. It would get bigger. If it's 4 times anything, it gets bigger. Or 4 times any number but 0. Okay, number 7, if I use a multiplier of 1/4 on a picture, so if I multiply the sides by a 4th, what would happen to the side lengths? 1/4 of something is like a portion, a piece, a portion that's less than a whole. So it's not going to stay the same. It's not going to get bigger. It's going to get smaller. It's a reduction. So it says for number 8, use the graph at the right. What is the coordinate of point A? So we need our x value and our y value. Remember that the x value is right and left, and the y value is left, the y value is up and down. And one way you can remember which one goes first is if you're using a ladder, you carry a ladder right or left to the place you're going to use it, and then you climb up it or climb down it. So let's look for our x value. So x is left or right. I start at the middle, the origin, and I go this way. I got to -4. And then to get to my point A, I go up. So I went left 4, up 1. Let's try B. So I start at the middle at the origin. I know I need to go to the right first. So I went to the right 3 for my x value. My y value, I go up. So if it's up, it's positive. And I went to 2 to get to my point. So notice the y value is the height. This one had a height of 2. And the blue one had a height of 1. It's how much I go up or down if you want a negative. So then we have this point here, point C. We have to plot it. That means draw it on the graph. Our x value is 2 and our y value is -3. So if I start at the origin again, which I always need to, the x value is 2. So that means I go 2 to the right, 1, 2. And the y value is -3. Negative means I go down, 1, 2, 3. And I end up right here. This is my point C. So these lines that I drew are not required, but they help me figure out what I'm doing. Here it says to write each improper fraction as a mixed number and each mixed number as an improper fraction. So we're converting between 2 different ways of showing these amounts. The first 2, A and B, are improper fractions because our numerator is greater or bigger than our denominator. So these are fractions greater than 1. I think the most efficient way to do this is long division. If you have another way, that's okay too, but you need to show some work. So I'm going to do 42 divided by 5. I say how many 5s go into 4? None, so I don't put a number there. I say how many 5s go into 42? And that's 8. You can use a multiplication chart on this test if you want to, if it would help you. Then I do 8 times 5. I get 40. I put it here. Then I subtract. I get 2. Now I don't have any numbers left here. Don't have any digits. And 5 can't go into 2, so I write my 2 right here. That's my numerator. My denominator stays the same because the denominator is like the size of the slices. We don't change the size of the slices. So that answer is 8 2/5. Okay, Same process here. We're doing 28 divided by 11. Remember, the steps of long division are divide, multiply, subtract, bring it on down, and bring it on back. We listened to that rap in class. How many 11s go into 28? 3 would be too many, so 2. Let's divide. Then we multiply. 2 times 11, we get 22. Then we subtract. We get 6. And then we would bring down a number, but there aren't any other digits to bring down, so it's a short one. So we see, we take this 6, and then we put 11 as our denominator. We keep the same denominator. All right, so those are improper fractions turned into mixed numbers. Now we're going to take mixed numbers and make them into improper fractions. This is a little bit shorter. We take these two numbers times each other because we have 3 whole pies cut into 7 slices each. So if we do 3 times 7, we know those whole pies are going to give us that 21 slices. But we also have the 3 slices already. So we're going to add 3 times 7, or multiply 3 times 7, and then add on the 3 to that, keeping the same denominator. 3 times 7 gets us 21. Then we need to add 21 plus 3. We get 24, and our denominator is the same. So some of you might say, hey, but that's an improper fraction. That was our goal, to turn it into one. Let's try the next one. So we do 2 times 15. We add on the 7, and we keep our denominator the same. So 2 times 15 gets us 30. 30 plus 7 gets us 37. We have 37/15. So instead of saying we have 2 whole pies and then 7 slices that are each 1/15 of a pie, this is like saying we have 37 slices that are each 1/15 of a pie. Either way, same amount of pie. Okay, back page. Multiply each of the following, show your work, simplify the fraction in B, put in lowest terms. So A is multiplying decimals. The first step we do when we multiply decimals is we multiply the numbers as if they had no decimals. We pretend there's no decimals. You can do this the way you like to multiply. We learned the generic rectangle in this course, so I'm going to do it that way. So I'm going to write 72. I split 70 into 72. 81. Then where each piece meets in the middle is where I put their product, or what I get when I multiply. And again, you can use a multiplication chart. 8 times 7 is 56. So 70 times 80 is 5,600. Normally I'd put a comma, but because I'm going to be moving the decimal around, I'm just going to skip that. This box we do 2 times 80. 2 times 8 is 16. Put that 0 from the 80. 1 times 70 is just 70. 1 times 2 is just 2. Then I add those numbers. So I write them out on the side. My sum is, okay, let's see, I have 2 in the ones column. 6 plus 7 is 13. I get 8 and 5. So that looks like our answer, but we have to deal with the decimals. We count for each number how many digits are past the decimal. Here's 1, 2, 3. So that means I move my decimal 1, 2, 3. So I start my decimal to the right of the last digit there. So my decimal moved right between the 5 and the 8. So I have 5, decimal, 8, 3, 2. And in a way that makes sense because I have 7, approximately 7, times about 8/10. You're estimating it. So you're doing less than 7. It's a portion. It's 8/10 of 7. Okay, this one, it says simplify the fraction. I am going to do this two ways. You can choose which way you would like to do it. The first way includes canceling. So what I would do is see if any of the numbers in the numerator match the numbers in the denominator, or if any of their factors match. 7 is prime, so I'm going to leave that. 5 is prime, so I'm going to leave that. Now I'm looking at the 4. 4 has factors 1, 2, and 4. I want to see, does 12 have any of those? And I'm going to look at the biggest number first. 12 has a factor of 4. So instead of 12, I'm going to rewrite it as 3 times 4, because 3 times 4 is 12. So I rewrote everything the same, except I made this 12 become 3 times 4. Now we have a secret giant 1. This 4 and 4 cancel. So our numerator is 7, and our denominator is 3 times 5, which is 15. That's the newer way. The way we used to do it, which you can still do, I take my problem, I multiply across the top. 7 times 4 is 28. 12 times 5 is 60. And then I list out my factors of 28 and 60 and find the one that's the biggest that they have in common, the greatest common factor. So factors of 28 are 1, 2, 4, 7, 14, and 28. And you could list them out for 60, or you could just check to see if there's any matches. 28 doesn't go into 60, 14 doesn't, 7 doesn't go into 60, but 4 does. So I can take my 28 60ths and divide using a giant 1, because then it's still the same value. It's an equivalent fraction. 28 divided by 4 is 7. 60 divided by 4 is 15. Same answer. You can choose which way you do it. Okay, so this chart is a lot like your quiz. We have fractions, decimals, and percents, and we're making each one have all three formats. So we have 6/20ths here as a fraction. There's this really cool hint, make it out of 100 to convert. So we make an equivalent fraction. We want 100 to be our denominator. To make sure it's an equal or equivalent fraction, we multiply by a giant 1. We want to see how many 20s go into 100. I did print some multiplication charts that have 20s, but we could just count by 20s to check. 20, 40, 60, 80, 100. So 5. Giant ones have to have the same numerator and denominator. I do 6 times 5, I get 30 per 100. Per 100. Right away, I thought percent. So percent means per 100. Maybe I'll even write that there to help me remember. I could also say this as 30 hundredths. So what I'd want to do is make sure the end of 30 is in the hundredths place. So if this is the hundredths place, this is the tenths, and the decimal goes by the tenths, or the decimal goes by the tenths. And a 0 in front. I might notice that this 0 is unnecessary. So I could write it as 0.3, which is 3/10. I would mark either this or this as correct. Next row, we have 2%. Percent means per 100. So I could just write 2 per 100. If I wanted to simplify it, I would divide the numerator and denominator by the greatest common factor. 2 only has 1 in itself as factors, so that's how I knew to use 2. And I get 1/50th. So it doesn't say you have to do that, so you could just leave this. 2 hundredths. So I want 2 in my hundredths place, which means I need something in my tenths, but I don't have any tenths. So I'm going to put a 0. Then I need my decimal to make sure that this is in the tenths and this is in the hundredths. And then I put 0 in the ones. So that's 2 hundredths. Okay, moving on. Again, we're talking about hundredths a lot. This number ends in the hundredths place. So I will write 32 hundredths. If I want to simplify it, I divide by the GCF. Since that's optional, I'll just tell you it's 4. And 32 divided by 4 is 8. And 100 divided by 4 is 25. So it's the simpler fraction, but this is okay as your answer. And percent means per hundred. We're lucky because it's already as a per hundred. So we have 32%. This last one can trick people a little bit. 180%. That means greater than 100%. It's bigger than 100%. On the side, I might write myself a note 100% equals 1, like 1 whole. So I know if this is 180, it's going to be bigger than 1. The shortcut is percent is per hundred. Per hundred means divided by 100. So it's just over 100. So the shortcut as a decimal, dividing by 100 is moving the decimal place over 1, 2. So I get 1.8. I could write it out a long way, and that's okay. 180 divided by 100. Only one 100 goes in to 180. I subtract. I get 80 as my remainder. So I get 1 and 80 hundredths, which is the same as 8 tenths. So 1 and 8 tenths. Okay, we're getting closer to the end. Josie's recipe calls for 1/3 cup of milk, but she's only making half of the recipe. Remember, half means 1/2, and of is multiply when we're doing math. How much milk will she need? Optional, use a picture to represent the product. Product means times. There's another hint. So we have 1/2 of the original, which is 1/3. With fractions, we multiply across the numerators, 1 times 1, and then across the denominators, 2 times 3, 6. So 1/6 of a cup. To show this, you could take a square, split it into thirds one way and halves the other way. So if this is this portion here, if I shaded this column as 1/3, this portion here, if I shade this way, is 1/2. The part where they would overlap is this middle part. And I guess I didn't label this. This is 1/3 and 1/2. Where they overlap, so that red part is 1/6. I originally taught you to shade it like lines this way for 1/2 and this way for 1/3, and where they overlap, where it's darker, is the answer. Show your work, this is 13, / method as you calculate the area. Label units. So I want to remind myself area, I put a little 2 on the units. So this one doesn't have units. I'm going to make it up. I'm going to call it centimeters. Parallelograms, we do base times height. The base and the height have to be perpendicular. Okay, so I see this little square. That means 90 degrees are perpendicular. So I want this as my height, and my base always has to be one of the sides. But I don't know that green side, but it's the same as the one across from it. So my base is 6 and my height is 5. A shorter way to think of it was just those two numbers, the 6 and the 5 are perpendicular. So you multiply them, you get 30, and I'm going to say centimeters squared, or we didn't know the units. You could say u squared. Do not put the 2 on the 30, because that would mean 30 times 30, and we get 900, which is something totally different. So 30 centimeters square, or square centimeters. Triangle, we also do base times height, and then we divide by 2. You could think of it instead as 1/2 of the base times the height. So that's your choice, which way you want to think of it. So our base is 5, and this is not to scale. So pretend this whole thing is 5. That doesn't really make a lot of sense. So we have 5 is our base, and our height is 12. And then we're going to divide by 2. So the picture isn't great, so I'd say it's not drawn to scale. I think this picture was originally supposed to do something called the Pythagorean theorem. So ignore that. We're just going to pretend that this looks like 5 and that this looks like 12. So 5 times 12 gets us 60. And then we divide by 2 and we get 30. And it's area, which is the inside, like the tiles. So we write 30 inches square. Okay, let me know if you have any questions. You guys have got this. Take your time, study every question, and I'm sure you'll do great.